All right, guys, so now we're going to talk about some of the special cases that can happen if you're trying to solve equations with variables on both sides. So something weird that can happen is actually you do all your inverse operations, you're trying to isolate the variables, and all of a sudden you realize that you have no variables left. They all have eliminated, and you're left with just numbers. That is completely okay. We just need to know how to interpret that. So the first thing that could mean is you have the identity. So this occurs when the variables are completely eliminated, you're left with just numbers on each side of your equal sign, but it spits out a true statement, something like 2 equals 2. If that's the case, then your solution is going to be all real numbers. What that means is you can plug in any number you want into that equation, and it's going to spit out a true statement. Okay, but the opposite of all real numbers would be no solutions. Okay, this happens when you do all your solving and you're left with something that doesn't make any sense. Something like 0 equals 2. You know that is a false statement. You know that 0 is a completely different number than 2. Those things are not equal. If you do all of your inverse operations correctly and you're left with a false statement, you know that means there's no solution. Okay, so a little bit confusing, but let's just break it down into basically the 3 different types of things you could see if you're doing an algebraic equation you're trying to solve. Okay, the most common type of thing you're going to see when you're doing algebraic equations is something like you'll do all your operations, you'll end up with something like x equals a number. Okay, that's most likely the most common thing you're going to see, something like x equals 7. One variable equals one number. If this is the case, that means there's exactly one solution that works for that particular algebraic equation. Okay, x equals a number, y equals a number, that is one solution. Okay, you could be doing your inverse operation, get to the final step, and you get what we call like a true statement. Something like 2 equals 2. Okay, these two numbers are certainly the same, and if this is the case, you know that your solution is going to be all real numbers. You can plug in any number you want into that equation and you'll get a true statement back. Okay, something I want you guys to be able to know, not super important, but we got to get a little bit more literate with our math symbols. If you see like this little double R symbol, that's just a fancy way to write all real numbers, and these are called curly brackets around it in set notation. And the last thing that could happen is if you're doing your algebraic operations, you could be left with an untrue statement, something like 0 equals 2. That doesn't make any sense. That means it would be no solution. No sense right here, no solution. And the fancy way you might see that written is like in curly brackets, you'd see like a 0, but a big slash through it. That means there's no number I could plug into my algebraic equation to get a true statement. Okay, so let's do some examples. Here we see 3 times the quantity x plus 2 is equal to 3x plus 6. The directions say solve, so we want to try to get x all by itself. Okay, so when I look at this question, the first thing my eyes go to is I see 3 times all of that stuff in parentheses. Let's use the distributive property and try to ultimately solve this. I'm going to take this 3 and distribute it to both the x and to the plus 2. First step is I'll have 3 times x, which I know is just plain old 3x. And then I see 3 times positive 2. 3 times positive 2 is plus 6 after I distribute. On my left side, I got 3x plus 6 after I distribute. And on my right side, I also have 3x plus 6. Okay, that looks pretty similar, but let's just keep going and see what happens. Let's try to get my x's on the same side. What I would do here is I would subtract 3x from the right and move it over to the left. These guys will cancel, and I know that 3x minus 3x is equal to 0, so my x's basically go away on both sides, and all I'm left with is positive 6 equals positive 6. Okay, so what happened here is my variables eliminated. I'm left with a true statement. I know that 6 is the exact same thing as 6. If that is the case, what I know is this is all real numbers. I can plug in any number into this equation and I know I'll get a true statement back. If it's a true statement, it's all reals. Okay, in comparison, let's do another one. I've got x plus 2 is equal to x plus 4. Okay, let's do what it takes to try to get that variable all by itself. How about I try to combine my x's? I see an x on the left and I see an x on the right. Let's take this 1x and move it over to the left. If I have positive 1x on the right, to move it over, I have to subtract 1x. And what happens here is these guys go away, and then x minus x is just 0. So what I'm left with on my left side is just plain old positive 2. And on my right side, I have plain old positive 4. Okay, my variable's eliminated once again, and I'm left with 2 is equal to 4. Okay, that doesn't make any sense. Okay, I know that 2 is a completely different number than 4. If it doesn't make any sense, if it's no sense, it's no solution. There is no number that I could plug in for x that'll spit out a true statement. And then here's the last one. I've got 2 times the quantity 5x minus 1 is equal to 3 times the quantity x plus 11. Okay, I see some parentheses and I see some numbers outside the parentheses. To solve this, I'm going to try to distribute on both sides. Okay, so I see 2 times all that stuff in the parentheses. I'm going to take this 2 and distribute it to both the 5x and the minus 1. Okay, let's be careful here. 2 times 5x is equal to 10x. And then 2 times negative 1 is going to be equal to minus 2. Please be careful with that minus, okay? That minus carries down. 2 times negative 1 is minus 2. Do the exact same thing on the right. 3 times the quantity x plus 11. This 3's got to distribute to both the x and to the positive 11. Okay, I know that 3 times x is just 3x, and I know that 3 times positive 11 is equal to positive 33. Okay, so I'm trying to solve for x. I'm trying to get all of my x's on one side, and I'm going to try to get all my numbers on the other side. So first thing I might do here is I might try to add 2 to my right side. So I don't have to subtract 33. After I do that, I'm going to be left with 10x on my left is equal to 3x plus 35 on my right. 33 plus 2 is equal to 35. Now I'm trying to get all my x's on the same side. I'm going to move this 3x over to the left by subtracting 3x from both sides. I got a positive 3x on my right. The way to get rid of it is to subtract 3x. 10x minus 3x is going to be equal to 7x. And on my right side, I'm just left with plain old 35. And I'm super, super close at this point. I know that 7 times x is equal to 35. I want to isolate this variable completely. How do I get rid of multiplying by 7? I have to divide by 7. 7x divided by 7 is equal to just plain old x. And then 35 divided by 7 is equal to 5. My variable is completely isolated and it's equal to a number. There's only one number I could plug into this statement that'll spit out a true statement, and it's x equals 5.